Sometimes expressions might appear equivalent, but they may not be exactly. So how can you tell for sure? Now, I told you last time we met that I was sad that I wasn't here that day because we got to talk about asymptotes. Okay? And I just want to remind you the rules about asymptotes. Number 1, we do not unnecessarily stress the first syllable of the word asymptote. Number 2, we do not abbreviate the word asymptote because even if we did, it would be ASY and not what you want it to be. And number 3, we don't walk around the hall telling each other we're going to kick each other's asymptote. Okay? Miss Clara will understand. Miss Brazel will understand. Miss Patton will understand. Others may not. Okay? So, we need to... Oh, sorry. But I'm really glad I'm back today because not only do we get to talk about asymptotes, we get to talk about holes. And in my juvenile high school mind, that's funny. So if you think it's funny, that's okay. Okay? Sir? No. No. She does. So, now the mathematical word is removable discontinuities. That's why the title of this paper is Removable Discontinuities. Okay? But the layman term for removable discontinuities are holes. Okay? Are you guys going to giggle every time I say holes? Okay, it's going to be a long class then. Okay? All right, so you all got your calculator when you came in, right? Right? Do I need to close my eyes for 5 seconds real fast? Okay, ready? 1, 2, 3, 4, 4.5, 4 3/4, 4 7/8, 4 11/12, 4 33/34, 4 49/50. 5. Okay. So, here's two functions, y sub 1 and y sub 2. Okay? Now, you know in your calculator, it's F1 and F2, right? Please understand that this worksheet is meant for the old calculators, so there's some things that are going to be slightly different in the explanations, but I'm going to actually show you an old calculator so you know what they're talking about. Okay? So first of all, I want to show that the two functions above are equivalent by factoring and simplifying y sub 2. Now, when we first talked about factoring, we told you, I'm not talking about myself and like some weird person. You remember that was Mr. Johnson who went through factoring with you, right? Okay? We talked about factoring with you. We said you're going to need it again, so we may need to go over it a little bit today to remember. Okay? But let's factor y sub 2 and see what happens. Y sub 2, is there anything I can factor in y sub 2 out of the numerator? No, it's just an x, right? Is there anything I can factor out of these two terms in the denominator? What are both of these terms divisible by? An x, okay? So if I factor out an x of each term, if I divide an x out of each term, what do I have left? X plus 2. Now, something to remember real quick. I'm going to go right at the top of my paper. If I'm saying 4 divided by 6, I can simplify that fraction by saying 4 is really 2 times 2, and 6 is really 2 times 3. And there is a common factor in the numerator and the denominator, and what happens to that? It simplifies to what? 1. 2 divided by 2 is 1, right? That's why when we simplify 4 sixths, we get 2/3. Okay? The same thing happens here. I can simplify factors that are the same in the numerator and in the denominator. So what should I be able to simplify here? X, right? So be real careful because some people try to do this. Shh. Every time you try to do that, a kitten dies. Especially not cat fries. Okay? I can simplify this x with what x? Because it is a factor, right? This is not a factor, it's part of another number. I can simplify that to be what? 1, because anything divided by itself is 1. So this equals 1 over x plus 2. Well, guys, what else equals 1 over x plus 2? Y sub 1. Absolutely. Okay? So what did you just tell me about y sub 1 and y sub 2? They're equivalent, okay? I'll go with that for now. In your calculator, first of all, turn it on. Okay? In your calculator, I need you to make a new document that is a graph. And in in F1, we're going to put what's labeled on our paper as Y1. Now remember, we have this division key, so we know for sure exactly what's in the numerator and exactly what's in the denominator. When I put that into F1, I can press Control T to go to the table. So I can fill in this table. It's asking me to generate the table for each function. So I can make sure I'm at -2. What's happening at -2? Undefined. Okay? Undefined. What's happening at -1? 1, y is 1. When x is 0, what is y? 0.5. When x is 1, what is y? 0.3 repeating, right? And what happens when x is 2? 0.25. Good. Now I'm going to press Control T again because I don't really want to mess with the table right there. Okay? Because I need to put y sub 2 in now. Now I'm not going to need y sub 1 anymore, so I'm going to go ahead and arrow up here and just delete that. I could put it in F2 if I wanted to. That's fine. Either way is fine. X over x squared plus 2x. So now I have y2 in my F2 function of my calculator. When I press enter, now again I can press Control T to go to the table. And again I want to adjust it so that I can see I'm starting at -2 on my paper, right? What's happening when x is -2? Y is undefined. What's happening when x is -1? 1. What's happening when x is 0? 0.5? No? Huh. Undefined. All right. When x is 1? 0.3 repeating. I'm writing 3 just because it's 3 and there's 3 of them. Just, it doesn't matter. What about when x is 2? 0.25. Well, now I'm confused. Because you told me by factoring and simplifying that they are the same. You even said they're equivalent. You used an excellent math word. Are they? In what ways are the tables not equivalent? So the place that they're not the same is at x equals 0, right? That's where they're not equivalent. Because this first equation had a 0.5, it had value, and the second equation says it's undefined. So sketch the graph. Well, we saw the graph several times, right, of y sub 2. Control T. Let's go back just to make sure and look. So we have like this and like that, right? So we're talking specifically about y sub 2, about this column of the table, this equation. How many vertical asymptotes does it have? It has one right there, doesn't it? Where's the other one? You said there's 2. Where's the other one? It only has one. Only one vertical asymptote. Does this match with the information in the table? Does it match with the information in the table? What makes a vertical asymptote in the table? Where it says undefined. How many times is undefined in the table for y sub 2? Twice. So how many vertical asymptotes do you think we should have? So does this match the information in the table? No, because it looks like there should be what? 2 vertical asymptotes. I think you used that abbreviation on your worksheet last time we met, right? VAs, vertical asymptotes. So my brain is going, something's weird. Something's going on. Okay? So let's look real quick at number 4 before we make any sort of decision or judgment. Okay? Find the vertical asymptote to this function. Please remember from last time we met and tell me, how do you find a vertical asymptote? Or read the rest of the question. Oh, set the denominator equal to 0. Excellent. 2x minus 6 equals 0. Do you remember that that's how you find a vertical asymptote? Now that I say it, or now that you read it, yes, it's all coming back to you? Okay, good. So if I add 6, I get 2x equals 6, and then if I divide by 2, I get x equals 3. How many of you could have told me x equals 3 after you wrote that? Anybody? Okay, I'm okay with that. So let's generate a table for this function. Okay? So on our, on our calculator we need to make a graph, or just use the one we had before. I'm going to make myself a little fraction. I'm going to say x squared, God bless you, minus 3x, God bless you, over 2x minus 6. Okay, so do I have it in there correctly? All right. So Control T to look at the table. Now, just so you guys know, my brain is going like this. Wait, something's weird. And I'm not even thinking about any of you guys. I'm thinking about this graph. So when x is 0, what is y? 0. When x is 1, what is y? 0.5. When x is 2, y is 1. When x is 3, undefined. When x is 4, what is y? 2. Does the table support the location of the vertical asymptote we found in number 4? Does it say undefined in my table? Yes. Because it's undefined at x equals 3. Sketch the graph of this function in the given window. Please don't do it yet. Why did I say something's weird? Do you know? Well, besides the fact that I'm a genius, why did I say something's weird? Because it's a line. You worked with lines all the way in 8th grade, all the way in Algebra 1. Did the equation for a line ever look like this? What did it look like? X plus 5. Y equals 2x minus 6. It didn't look like this, did it? So something's weird. Do you agree with me now that something's weird? Now, at this point, we have to stop the discussion for just a moment because I have to tell you, your calculators are too good for this problem. They're too good for you to see what I need you to see. Okay? And it has to do with the number of pixels on your screen. Okay? Here's an old calculator. I got it out so you could see it. Okay? Look at the graph if I show you on an old calculator. Let me zoom in. What do you notice? It's kind of dotted. It's got to do that again because of the size of the pixels, the number of pixels. Do you notice anything else? Me too. Does anyone else notice a missing pixel? Where is that missing pixel? Oh my gosh, at x equals 3? So what's happening at x equals 3? There's a hole. It's a hole. Okay? So when you graph yours, I would prefer that you graph it this way. Like the old calculators. Okay? I'd prefer that you graph it like this. Oh, sorry. Graph it like this so that you make sure for sure there's a hole right there at x equals 3. So there are at least 3 strange things about this graph. We're going to write 3 down. If you see some other strange things, that's fine. We'll talk about them, but there's 3 specific ones that I want you to write. Dylan, what'd you say? There's a hole. Go ahead and write at x equals 3, so we're specific. Okay? There's a hole at x equals 3. What else is weird? Emily, what'd you notice? It's a line. It's linear. And last thing? Austin, what you got? Okay. What did we do up here? We set it equal to 0. What were you trying to find? The asymptotes. Okay, show me where the asymptotes are on this graph. Oh, you're right. There's not any asymptotes. But didn't we expect asymptotes? We set the denominator equals 0. We even checked with our table and found it said undefined on our table right at 3. So we expected it to have something like this at x equals 3, didn't we? But there's not one. There's only a hole. Okay? Usually the values of x that make the denominator equal 0 will create what? A vertical asymptote. Unless, of course, that value, when we solve the denominator and make it equal to 0, we get a value. Unless that value makes we already know it makes the denominator equal to 0. Absolutely right. Unless it also makes the numerator equal to 0. When that value makes the denominator equal 0 and the numerator equals 0, this creates a removable discontinuity. Or a hole. So let me show you what I mean. If we're given this equation right here, first of all, we factor the numerator. When we factor this, all we can do is take an x out of each term, so we get x times x minus 3. Are you with me? Then we factor the denominator. And just as a quick reminder, This one's nice because it has a leading coefficient of 1, so we can find AC, which in this case is -3, and we can find B, which in this case is -2, and we say what two numbers multiply to be -3 and add to be -2? Well, we know that that is a -3 and a +1. -3 times 1 is -3. -3 plus 1 is -2. Do you remember that? So I write x plus 1 and x minus 3. Notice what happens right here. I have an x minus 3 in the numerator and an x minus 3 in the denominator. When that value would make the numerator equal to 0 and the denominator equal to 0, it's not a vertical asymptote anymore. It is a removable discontinuity, or a hole. But what happens to this other factor in the denominator? Guys, we still set it equal to 0, and that still gives us our vertical asymptote. But here's the deal. How do we figure out where our hole is? Don't we just set that equal to 0? If I say x minus 3 equals 0, x would equal +3. What's the x value at this hole? +3. Okay? So regardless, you're still going to set each factor equal to 0. You just have to know whether it's a removable discontinuity or a vertical asymptote. You have to be able to tell the difference. If it repeats itself in the numerator, if that factor repeats itself in the numerator, it is a hole. It is a removable discontinuity. If it does not repeat itself in the numerator, it is a vertical asymptote. Does that make sense? Okay, so if you plug an x value in and get a number divided by 0, that's going to give you a vertical asymptote. If you plug in an x value and get 0 over 0, what's that going to give you? Very good. But no matter what, we figured out back on the front of this page, no matter what is it going to say for the y value? It's going to say undefined no matter what. So what do we have to do to know for sure? We've got to factor. Okay? We've got to factor to know for sure. So look please at problem number 1. These are your practice problems for tonight. I'll do number 1 with you. The rest of yours are you to do before tomorrow. Okay? Look at problem number 1. What do I have to do first? Factor. This is nice because it has a leading coefficient. Yes, ma'am.
Can you send Emily Ellison to the office? She's leaving.
I sure will.
Thank you.
When we notice that the leading coefficient is 1, so I say in my head or out of my mouth, I have to multiply to be 8 and add to be 6. What are the two numbers that multiply to be 8 and add to be 6? 2 and 4. X plus 2, x plus 4. Then I look at the denominator. Again, the leading coefficient is 1, so my AC is -6 and my B is -1. What multiplies to be -6 and adds to be -1? Three and 2, what kind of each? X minus 3 and x plus 2, right? -3 times 2 is -6. -3 plus 2 is -1. So what do you notice here? Look. What do you notice right there? That happens in the numerator and the denominator. Set it equal to 0 to find your removable discontinuity. X equals -2. The other factor in the denominator, you set that equal to 0 to get the vertical asymptote. X equals 3. Horizontal asymptotes, you may want to remember or even look at that sheet that we had that I gave you last time that's called Finding Horizontal Asymptotes. And we say the degree is 2. The degree is 2. When the degrees are the same, we look at the leading coefficients. What are the leading coefficients? Y equals 1. 1 divided by 1 is 1. Okay? That's what you do for the other 5 problems. If you have any questions, please come by and see me. Otherwise, have a great day. Peace.